Okay, now the last thing that we're going to do is we're going to connect our GUI to our network component so that our GUI can make calls when necessary to the network component in order to store and upload points. Then after we do that, we're going to correct the location component, or we're going to actually put code in the location component so that we can get location information using the Unity scripting language that will be translated into whatever platform you export it to. So Android, iOS, a web-based player. So let's go ahead and do that. The first thing we're going to do is go back to our GUI script and get the network helper hook. All right, here we go. Okay, so meanwhile, back in code, for my network helper, that's our network helper script, back in our GUI script, what we want to do is we want to create something that will be a reference for us so that we can get access to the network functions when we need them. So we're going to use the name of the function that we have defined in our myNetworkHelper script. It's going to be a network helper. It will be private, and we'll call it network helper. Now on start, right after we check to see that the GUI skin has been assigned, we're going to go ahead and try and find that network helper and assign it. So we're going to say the network helper, and we're going to use the search model that we saw before. We're going to look through all the game objects. We're going to find the one called my network helper, and then we're going to get all of them. So we're going to find anything called my network helper. We're going to get all of them that are children or root levels of them that are of the type network helper. And we will return it. Okay. Save that, and if we come back to our Unity window and we get an error, we say network helper is a field, but the type was expected. So let's go back on 32. Network helper here, network helper here. Oh, here it is. Seems like it expanded the wrong way. I need the type here, which is network helper. Back to our Unity window, give it focus, it'll recompile, and great, looks like it worked. All right, so now within our GUI, if, for example, down here at some point we want to do something when the button is pressed, we can do network helper and then call whatever we want to do. For example, maybe we want to do something like address the stroke color of the pen, in which case we could use the function that sets the stroke color, like add. This doesn't make sense for the upload button, but we could put it here, add stroke color, stroke name, and color. So we could do that. And now we have a connection between our GUI element and our network element so that we can make those network calls. Okay, so the logic that you have to put into the GUI includes changing the color, deciding when to upload the points, and I think that's it. So the only other thing that you need to know in order to be able to figure this out is that there's a special Boolean variable called GUI.changed. So this will be set if between the last call and this current call something has changed. So if GUI has changed, that will be true. And so you might want to do something like, say, you want to check the difference between what the pen down was before. So you could say, for example, Boolean old pen down equals pen down. Set the new pen down to whatever the toggle button says. And then if the GUI changed, you can say, well, let's see if what changed in our GUI was whether or not the pen was down. And we can then put some logic in here and say that if the old pen down is not equal to the new pen down, then we can do something. Okay. Save that. Great. All right, so that's how you would add logic to your GUI in order to upload points and to capture points. Now, the only thing that we don't have right now is we don't have anything about location. So let's add that location component next. So our location component is going to be done in another script, and so we have 3 scripts, one that's managing the network calls, one that's managing the guts of the GUI, and one that's managing location. So let's go to location. All right. Right now, location is just a game object. It doesn't have any scripts to it, so we're going to add a script. And we're going to actually have my location do a little bit of graphical user interface as well. So first thing we're going to do, we'll do add a location. So my, it's called my location script. And let's spell it right. And it's C#, great. And terrific. And so now let's go there. My location script. Let's open it up. All right, so in here we have to put the logic for telling Unity to get latitude and longitude. So the first thing that we're going to do is because we're going to have this component give us some feedback on the UI, we're going to have it use a skin just like before, just like our primary GUI object. And we're going to have an onGUI function here as well that will run some GUI objects. And within that, we want to make sure that the skin that we're using is the skin that has been assigned. And if we save this and we go back to our Unity script, because we added a public variable, we should see that in my location, we have a place for the GUI skin to be placed. So let's go ahead and take our skin that we've been working with and add it there. All right, going back to our script now. All right, how do we actually go about getting our location when we want it? Well, what we're going to do is we're going to put it within our start function. And we are going to create a local variable that helps us know whether or not the location services are working. So we'll say working, private boolean, working, and when we start off, that's going to be equal to false. So for our start function, we're going to use a method that C# has that is available called the enumerator, and called some yield functions and an enumerator. And what this enables us to do is to wait for things to happen and to add some tactic sugar to being able to look at some to modify enumerated items. All right. So the first thing that we're going to do there is we're going to get a hook to, this is still housekeeping, we're going to get a hook to our network object and to our GUI object, just like we did in the last time, just like we did in our GUI object, so that we can call functions as necessary. So let's have our private network helper, I'll call that network helper, and we'll have a GUI called, we don't want to confuse it with the other ones, we'll call it the local GUI. Great. The first thing that we're going to do here is we're going to say, okay, our local GUI is going to be a game object that we're going to find by looking for my GUI, and we'll get the component, we'll get anything in the hierarchy there that has the type my GUI, great. And then we'll do the same thing with our network helper. Network helper, our local reference to our network object. And that's where it keeps auto-replacing in a way I don't want it to. Shoot, stop that. So we have hooks to our graphical user interface, we have hooks to our network helper. That's the first thing that we do in start. The next thing that we're going to do is we're going to make sure that our GUI skin has been assigned. And if it hasn't, then we're going to add a debug statement by passing it to our local GUI, saying that our GUI skin hasn't been properly set. And rather than just returning false, we'll use this construct called yield return false, which works with the IEnumerator return. Okay. So the first thing that we're going to do is we're going to check to see if the user has enabled location in their application at the operating system level. We'll do that here, and we say input is provided by Unity, location is an object there, and if it's enabled by the user, then if it's not enabled by the user, then we'll raise an error. And if it is, then we're going to go ahead and start the location component here. So this tells Unity to start whatever platform you're on, start trying to get the location. And these two parameters are the accuracy that you want location updated with. So this says 1 meter in floating point, and this is how much it has to change before you get an update. So I want to know within 1 meter accuracy every time 1 meter changes. So that's really high accuracy, and it's probably only going to be able to be provided by GPS. Okay, so the next thing that we want to do is we want to wait for our system to initialize. So we'll say, okay, we're going to wait for 20 seconds, and the way we're going to do that is we're going to say while the location status is still initializing, and we haven't waited our full amount, we're going to use this syntactic representation to wait 1 second, and then subtract 1 from our counter. All right, after 20 seconds or after the service has initialized, we'll check to see whether or not it worked. Right? All right, if it didn't initialize, meaning we got through here and the wait timed out, then we'll say timed out and we'll return false. All right, if we didn't time out, then we'll check to see if it just plain up failed. If it failed, then the status will be set to failed, in which case we'll add a debug message here and we'll return false. Okay, if it didn't time out and it didn't fail, then we will go ahead and set our working variable to true. So if it didn't fail and it didn't time out, we'll go ahead and add a message saying what our current latitude and longitude is and our timestamp, and we'll set working equal to true. Now, if at any time in the future we wanted to stop the location service, what we would do is we would call input location stop, but in this case we don't want to do that. We just want to keep location running the whole time. All right, so now every time that there's a tick in the clock, there's not callbacks in Unity. So Unity doesn't have callbacks the way Android does. So we don't have the benefit of just being told when there's a new location. So what we're going to have to do is we're going to have to periodically poll for a new location. And where we're going to do that in this code is we're going to do it in the update function. The update function is called once per frame during the animation, and we'll check to see first if the location has changed, and then to make sure, first we'll check to see if it's working, and then if it's changed. And if it has, then we'll do something. Okay? All right, so on update, we say if working is true, so if we even have location working from our startup, then what we'll do is we'll check to say, well, we don't really care if there's a location if our pen was up. So we'll check to see by using the hook to our local GUI if the pen is down. And if the pen is down, then we will collect, then we can check to see if the location has changed since last update, and if it has, add it to our network helper. Okay, so the way that we get our location is we use the construct input.location.lastData. That's an object which has several elements to it. One element is longitude. Another is latitude. Another is altitude. And the other one that you're going to care about is the timestamp. All right, so if it's working and the pen is down, then you can check to see if the location has changed since the last update. So you're probably going to have to do something here like, say, create a local variable called last longitude, and check to see if last longitude not equal to the current one, then you're going to do something. All right, so the logic here is for you to implement, for you to go through and say, okay, if our location has changed, what do we want to do? And what you're probably going to want to do is add it to the network helper. And you should know that the network helper is smart enough that if you add points to it and there hasn't been a sufficient change in distance, then it's just going to discard it. So you're safe to add lots of points to the network helper. It's not going to overload the buffer there. However, it doesn't help to, you can do a check to see if it's changed if you want, although actually you don't really have to. It's just going to, every time you add a point to the network helper, it's going to check the distance and possibly slow down your animations and slow down your app. So it makes sense to check to see if they're exactly the same before checking to see if the distance has changed very much. Okay? Okay, so that concludes the location elements of it. And so if we go back here to our Unity environment, our integrated development environment, let's make sure that we have errors. We don't have errors that we can't fix. So my location script line 9 had a problem. Let's fix that. It says it doesn't know about my GUI. So my GUI should be, oh, it's my GUI script is the name of the object that we use here. That's the class. And so what we should call it in my location script, we should just call it my GUI script. And then what new errors do we get? Say only assignment call decrement new object can be used as statements. Line 71. That's probably, yeah, here. My GUI could not be found on line 15. Class type in the generic should be my GUI script. What else do we have? 20. Local GUI does not exist in the current context. That's because we called it local GUI. And the last one on line 66 I missed. Okay, great. So we're compiling. Okay. So let's run it and see if we get what we expect. Oh, the last thing, the very last thing that I want to do is I want to add something to our location script. Here's our location script. On GUI, I want to add one last thing that will show our last location. And so just like there's nothing special about our GUI script that we made before. That was just something that we made to help us organize our own interface with the graphical user interface. Any of these scripts can have interfaces with the graphical user interface. So one last thing that you might want to do down here is to give some update about what information you're getting from your location updates. And so you may want to do something like, say, GUI.label, a new rectangle. If we put this at the bottom of the screen, so we say x position 0, and y position screen height height minus 100, and we'll have it be the length of the screen, the width of the screen, sorry, and we'll have it be 100 high, and then the information that we'll put there will be a collection of whatever our last information is. So we'll say input location.last data.longitude, for example, although that may not be the right thing that you want to put in there. Okay, great, and we'll spell it correctly so we don't get an error. And then when we go back to Unity, if we run it, what do we get? Error on line 83. What's wrong with Google? Oh, I didn't capitalize label. Okay, and then we run it, and we can see that we have all these elements that we have access to. And if we go down to the bottom, we see our location estimate is 0 because we're running it on the web, or we're running it in the player. Okay, so in summary, what did we do? We created a user interface within Unity using GUI elements. We have a skin that controls the font size. Okay, so we didn't mention that. In the GUI here, if you would like to increase the font size because the font is way too small in Android, for example, you can come to the skin and you can edit the different components here in the skin. So for example, in the text field, you can set the font. Okay, so let's see. So for example, in our GUI, in our user interface, we have a button. And in our button, we may want to change the let's look at our first one. In our group name is a text field. And so when we look at our skin, we look at our text field, we want to change what we've got for our styling for our text field. So when we run our application, we see our group name has this font and this size. If we stop the player running, we can go to text field and we can say, okay, I want to set the font to the built-in font Arial, and I want to give it font size 50. This will be important because if you run it on your phone, then you're going to find that the default font size is too small. Okay, so we save that. Oops, sorry, that's saving the scene. And then we run it, and we can see by editing this styling guide in our skin, we change all the instances of text fields, font to Arial, size 50. And you can see that's reflected in the user interface. That's the whole reason we used the skin, is so that in one place we could change the styling for all the different elements without too much trouble. Okay, so in summary, what we did is we made an application for a variety of different platforms using Unity. We're leveraging Unity because it does cross-platform compiling, and so we're writing our location scripts and our GUI scripts in C#, but using libraries that Unity knows how to translate into the specific platforms that we're going to access. When we run this, we're going to get location from whatever platform we're on, and once you add the logic to collect that information and add it to the network helper, then you'll be able to record the places where you're going. All right? So apart from the things that I've just done here, the additional logic is really quite simple. You're probably talking about maybe at most 20 additional lines of code in order to check to see if the pen is up or the pen is down. And if the pen is down and you get a location, then you add it to the network helper. And then when you hit the upload button, you call the network helper to upload the data. And it's going to the same website that it was before. Okay, thank you for your attention. Good luck.